Guys, I'm Engineer Annabelle, and today I'll take you through a short revision of mathematics. That is CDAC, Mathematics, Level 6 and Automotive. And the question that I want to revise here with you, it was set by a trainee just like you on the year 2023 July. August is a CDAC paper, an examination paper, you see. It was set on July 2023. July 2023. July 2023. So that is the question that is the paper that I want to revise with you. So cooperate. If you are new, remember to subscribe, like, comment, and the most important part, remember to share for others to also benefit from this kind of a revision. So I'll paste for you these questions on the dashboard for you to see. Question number 1 says that express z, which is 2 minus z7 in polar form by calculation. Let me write the equation for you. See that express z, which is 2 minus j7 in polar form by equation. This is the equation. That was question number 1 that year, mathematics level 6, automotive, CDAC. That express z, that is 2 minus j7 in polar form by equation. This question, as I look it, was derived in a topic known as complex number. This is a complex number. Why? Because it has the coefficient of j. It was derived in a complex number. To form a complex number into polar form, how does it being represented? It is represented by modulus greater than, and modulus is less than angle argument. See, this is how polar form is always represented, that modulus is less than argument, or argument is greater than modulus. That, remember. So for you, let me break this question for your understanding. Let me represent this complex number in a Gantt diagram for you to understand it better. So this is a Gantt diagram that I'm drawing. This is 0, 1, 2, 3, 1, 2, 3, 2, 4, 6, 7, 8, 2, 4, 6, 7, 8. So it is 2. Remember, this is the 2 minus j7. This is the complex number itself, where 2 is always the value of x and y. J7 is the value of y. The first digit in a complex number is always the value of x, and the second digit of the complex number is always the value of y. So is 2 minus 7, 2, negative 7. This is negative, this is negative, this is negative. Don't forget to get j. So it is 2, negative 7. Let's say somewhere here, there. So this is how you represent. This complex number in a Gantt diagram. Remember, this is a Gantt diagram. Some question may tell you that express this complex number in a a Gantt diagram. But for your understanding, let me break it for you. So this is the how you present your complex number in your Gantt diagram. That is 2 minus j 7, where this is x with the value of x, and this is the value of y. This is the value of y. And this is the argument that you must look for. That is the argument. And this is the hypotenuse of the triangle, and it's always noted by r. This r is the same as the length, it's the same as the size, it's the same as the modulus. Understood? So as I said earlier, that to represent your polar, you have to find the modulus and the argument. Let's start with the modulus. Modulus is the same as size, it's the same as length. Understood? And to find the modulus, there's something known as a trigonometry. Trigonometry are rules that you have to do. This is the theta. To find hypotenuse, they always say a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. But when you see this triangle, we have the value, we have x, y, and r. So it will be x squared plus y squared is equals to r squared. This is the c. My friends, my colleagues, see this, store it in your head. It will help you one day. So this is what you're looking for. So x is 2. So 2 squared plus y is negative 7 squared is equals to r squared. This 4 plus 49 is equals to r squared. It will be 53 is equals to r squared. So r will be root of 53, and this is the modulus. This is the modulus. So to find, that was the modulus. To find the argument, we say that argument is the same as angle between, is the same as theta. So we want to find this theta. This is a right angle triangle. To find theta, we always use a trigonometry law or trigonometry ratio, that is SOHCAHTOA. Where you use, engineers always work with what they have. When you look at a triangle, we have hypotenuse, we have the value of adjacent, and we have the value of opposite. So look, adjacent and opposite, that is tan obvious. So tan theta is equals to opposite over adjacent. That will be tan theta is equals to opposite, that is y, adjacent is x. So to find theta is tan inverse of y over x. Substitute with what you have. What is the value of y? The value of y is negative 7. So tan inverse of negative 7 over x, the value of x is 2. I know some are asking where I'm getting the negative 7. Negative 7 is here in our equation. 2 minus j7. 2 minus j7. So this is the value of y. Since I say that the second digit is always the value of y. So y is negative 7 and x is 2, positive 2. This is the value of theta. When you find this in a calculator, that is tan inverse. Remember for you, shift tan for those who that is tan inverse, then negative 7 over 2. Answer give you negative 74.05 degrees, and that was our argument, that is negative 74.05 degrees. And this is the argument. This is the argument. The argument. The argument. And because the law of mathematics say that when you present a polar form in a complex number, it is always argument, not argument. It is always, modulus versus argument. Modulus versus argument. So our modulus is 53, that is root 53. Then our argument is negative 74.05 degrees. Understood? If you simplify this, root 53, that is 7.2. That is 7.28. See, 7.28 root 53 with 7.28 negative 74.05 degrees, and this is your answer. It is complex. In this question, I will tackle the argument, a polar form, a grand, and also I've given a law that comprises the complex. This law, x squared plus y squared is equal to r squared. Understood? Let me go to question